In this video, we'll learn how to choose a correct test statistic for a hypothesis test. We'll focus on three choices: when to use a z-test, when to use a t-test, and how to apply these ideas in a full example. Let's begin. Once we know whether the problem is about a population mean or a population proportion, the next step is choosing the correct test statistic. There are three simple rules. If we are testing a population mean and the population standard deviation sigma is known, we use a z-test. If we are testing about a population mean and the population standard deviation sigma is unknown, we use a t-test. If we are testing about the population proportion, we always use a z-test. So remember, mean with sigma, use z-test. Mean without sigma, use t-test. Proportion, always use z-test. Let's look at example 1. A study measures the average height of adult women. Population standard deviation is known. What test statistic is calculated for this scenario? Since we are measuring an average, this is a test about a population mean. The problem also tells us that the population standard deviation is known. So we use z-test. Now, let's look at example 2. A study measures the average salary of engineers. Population standard deviation is unknown. What test statistic is calculated for this scenario? Again, we are measuring an average. So this is a test about a population mean. But this time, the population standard deviation is not known. So we use a t-test. Now, let's put everything together. Example 3 says, a city believes that more than 75% of households recycle regularly. A survey of 400 households is conducted. Let's answer part A through H. Question A asks for the symbol of the random variable. Since we're working with the population proportion, the random variable is p hat. You might be wondering why we use p hat instead of p. Remember from chapter 7, we learned about sampling distributions. When we take many random samples, each sample has its own sample proportion, or p hat. Since p hat changes from one random sample to another, it is a random variable. And if we're testing a population mean instead, the random variable will be x bar, the sample mean. Just like p hat, x bar changes from sample to sample, so it is also a random variable. On the other hand, p and mu describe the entire population. They are the population parameters. Since this problem is about the population proportion, our random variable is p hat. Question B is asking for the wording for the random variable in context. P hat is the proportion of the 400 randomly selected households that recycle regularly. Notice that this describes a sample, not the entire city. Question C asks for the symbol for the parameter involved in this problem, that is P. We use P because this problem is about a population proportion. Question D asks for the wording for the parameter in context. P is the proportion of all households in the city that recycle regularly. So the difference is P hat describes the sample. P describes the entire population. Question E asks for the hypotheses. We want H naught and HA for this problem. Let's look at the problem. A city believes that more than 75% of households recycle regularly. More than 75%. That means P is greater than 0.75. So this is my HA because HA does not contain the equality sign. And H naught uses the equality. So we have P equals 0.75. Be careful here. Hypotheses are always written using the population parameter. So we use P, not P hat. Question F, we want to describe the type 1 error. A type 1 error means we reject the null hypothesis when the null hypothesis is actually true. In this problem, that means we conclude that more than 75% of households recycle regularly, when in fact, it is 75%. Question G. We want to describe the type 2 error using the problem's context. A type 2 error means we fail to reject the null hypothesis when the alternative hypothesis is actually true. In this problem, that means we fail to conclude that more than 75% of households recycle regularly, when the true proportion really is greater than 75%. And finally, question H. What test statistic is calculated for this scenario? This problem is about a population proportion. For a population proportion, we always use a z-test.